Okay, this video is going to cover the questions on worksheet number 20, questions 1, 2, 4, 5, 9, 10, 13, and 14 for the questions that are recommended from this section. These are all similar to questions that will be on the test, so if you don't understand them, this video hopefully will help you help guide you to understand how to solve them. Okay, the first one says a parabola contains the points 10, 66, 324, and negative 144. Find the equation two different ways. First, use the regression capacities of your calculator, and secondly, by writing down a linear system of three equations and solving for A, B, and C. Now, the first one we're going to do is write that linear system. We're going to use our calculator and a matrix equation to solve for those variables. So the first one is the ordered pair 10, 66. That means that x in our equation f of x equals ax squared plus bx plus c. So the 66 is the f of x, and the 10 is the x value. So set up the system of equations. So the value of the system is equal to 24. Okay, so from these three equations right here, you should be able to get a 3 by 3, three equations, three unknowns, and then we're going to write that as a matrix equation. So this becomes 66 is equal to 100A plus 10B plus C. Then 24 is equal to 9A plus 3B plus C. And then finally 44 is equal to A squared minus B plus C. So there are your three equations, three unknowns. Now we're going to set that up as a matrix equation. Remember, first we have the coefficient matrix. Which we will call A. And that's where we take the coefficients on the variables and put them into a matrix. Shouldn't be there. I multiply that times the variable matrix, A, B, C, and that's equal to that constant matrix, 66, 24, 44. Okay, that is the matrix equation. That's what it looks like. That's what you need to have written on your paper. At this point, you're going to enter matrix A into your calculator, enter B, and then you should get matrix A. Remember, it'll look like this when you call it up on your calculator, inverse times matrix B. And then you should get the answers on your screen. 1, negative 7. When you do that, you should get a matrix that says 1, negative 7, 36. So your equation is going to be x squared minus 7x plus 36. To use the regression function, remember you're going to enter the data, enter those 3 points, into your list, and then you'll go to Stat, over to Calc, down to Quadratic Regression. Okay, and then that should give you those same values for that system. You should be able to use both of those methods to solve a system. When given 3 points, you should be able to find that quadratic model either way. Second question says the income from ticket sales for a concert is modeled by this function. The income based on the price of a ticket is equal to negative 70p squared plus 3,500p, where p is the price of a ticket. First, do part A and B without using a graphing calculator. So calculate the maximum value of the function. Where does the maximum value occur? When you look at this function, you should recognize that it's going to open down and it will have a maximum value. Remember that maximum value occurs at the vertex. To find the vertex, we'll find the x coordinate at minus b over 2a. So that will be minus 3,500 over 2 times negative 70. That's going to give me an x coordinate, or a price per ticket, of $25. To find the maximum value, I will find the income as a function of ticket price. So I'll substitute the x value into the equation. The ticket price will tell me then the income. So you're just substituting in that $25 into this equation as the price. And you should get that is $43,750. So what you're doing is finding the maximum where the vertex is. That's where the maximum value is. So the maximum income is $43,750, and that is a result of a ticket price of $25. Next says confirm your answers to A and B by using your graphing calculator along with the calc menu option. So what would your window settings be? Well, it doesn't make sense to say you're going to charge less than 0 as your minimum. Now, if you think about this, what do we know about a parabola? We know that it is symmetric, about the axis of symmetry. For this problem, that axis of symmetry would occur at x is equal to 25. So that means I want a minimum at x equals 0 and a maximum at least x equals 50. That'll give me a good window. I'll be able to see the entire parabola. And then again, because we know what the vertex is 25 and 43,750, I know I'm going to need to see the whole parabola. I'm going to need to see a y minimum at y equals 0 and a y maximum at about 45,000. That will allow me to see the entire parabola. So y min 0, y max 50, or x min 0, x max 50, y min 0, y max 45,000. So it should be at least those values so that you can see the entire function. So you want to find the vertex You know that's the axis of symmetry, so your window will have to be twice as long as half of that parabola. Okay, next we're going to go to number 4. A rectangle has a perimeter of 60 inches. What dimensions would maximize the area? So what do you know about a rectangle? It has a length and a width. The perimeter is equal to 2 times the length plus 2 times the width. The area is equal to length times width. In this case, you are given the perimeter is 60 inches, so substitute that in. So P is equal to 60, 2 times L plus 2 times W. You can divide all of those terms by 2. So you would have 30 is equal to L plus W. Now, you want to get this down to just one variable. So solve this for either L or W. So 30 minus W equals L. So now, wherever I have an L, I can substitute in this 30 minus W. So the area is equal to 30 minus W times W. Gives me an area of 30W minus W squared. So then, if you find your vertex, remember that's where this maximum value will occur, is at the vertex. It's at minus b over 2a, the x coordinate. So that's going to be, let's see, minus 30 over negative 2, which gives me an area of, or excuse me, a dimension of 15. So actually, this is optimized when the length is equal to 15 and the width is equal to 15. Another way to think about it, if that way does not make sense for you, is to think about factoring this. Go ahead and factor this function. So it's actually already factored 30 minus W times W. That gives you the x-intercepts. So I guess that doesn't give me the maximum value. You would find that at minus b over 2a, which is the x-coordinate of the vertex. Okay, let's take a look at another one. I think I have another rectangle problem here. Let's take a look at it. A rectangle has the dimensions W and 170 minus 2W in feet. What width would maximize the area? What is the maximum area? So here, remember area is equal to length times width, so W times 170 minus 2W. That gives me 170W minus 2W squared. To find the x-coordinate of the vertex, I'm going to use minus b over 2a. So keep in mind when I'm looking at this graph, think about the graph. This is, the x-axis is width and the y-axis is area. So that means my vertex is going to be the x, width, and the y, area. Those values are width and area. So I'm going to find the x-coordinate of that vertex when I substitute in 170 over 2 times negative 2, which is going to give me 42 0.5 feet. So when the width is 42.5 feet, the area, remember we have the x-coordinate to find the y-coordinate, we will substitute in that x-coordinate. And that will give me an area of 3,612.5 feet. Okay. Next problem we're going to take a look at is number 9. It says find the equation of the parabola in vertex form, having a vertex of 3, 4 and a point 1, -4. We want to do all the algebra for this. Remember, vertex form is y equals a times x minus h squared plus k. My vertex, 3, 4, means that 3 is h and 4 is my k value. And then I have an x and a y with the ordered pair. What I need to find is a. So I'm going to have to solve this for a. So I'll substitute in everything else that I have. So I have -4 is equal to a times x, 1, minus h, 3 squared, plus k, which is 4. So I have -4 is equal to a times -2 squared is 4, plus 4, subtract the 4 from both sides. I will get -8 is equal to 4a. So a is equal to -2. I now have the value of a, and I have my vertex. I can write my equation. Y is equal to -2 x minus 3 squared plus 4. And that is the equation of the parabola with a vertex of 3, 4 and a point at -1, -4. No, not -1, -4. I used just 1. So let's cross that out. That minus. I did not see it over there when I typed that. That should have been fixed. So at 1, 4. At 1, 4. Next is number 10. Number 10 asks you to fill in the table. You have to find the axis of symmetry. Remember, you find the axis of symmetry using minus b over 2a. So here, minus b over 2a minus 2 over 2 times 1/3 is going to equal -3. The vertex, the x-coordinate is minus b over 2a. The y-coordinate is just substituting that value in. And here we should have a vertex at -3, 0. When we look at it, it's positive, so we know it opens up, thereby giving it a minimum value. The y-intercept is when we let x equal 0. So y is equal to a times x minus h squared plus k, or y is equal to ax squared plus bx plus c. Whichever form, you just make x 0 and solve for what remains. So for this first, I have y is equal to 1/3 0 squared plus 2 times 0 plus 3 gives me a y-intercept of 0, 3. Now going over to the second form, this is vertex form. This one's easier to find the axis of symmetry because you know the vertex for this is at minus 5, 30. So you know the axis of symmetry is at minus 5. You know because it's negative, it opens down. Therefore, it has a maximum value. The y-intercept, you'll just let x equal 0. So that will be y is equal to negative 2 times x plus 5 squared plus 30. Negative 2 times 25 plus 30 gives me negative 50 plus 30, which gives me a negative 20. So my y-intercept is at, what's a 30? Is at negative 20. Finally, number 13 and 14, it says solve this equation. So when it says solve, that means we want the values of x that will make it true. We can do this by the square root method or by factoring. We use the square root method. 3x squared is equal to 18. Divide by 3. X squared is equal to 6. So x is equal to plus or minus the square root of 6. And that's the solution to that equation. Number 14 asks you to factor this 3x squared minus 12 completely. So you have 3x squared minus 12. The first thing you want to look for is a greatest common factor. Factor out the 3. You're left with x squared minus 4. Then you should see the difference of squares and factor that. So 3 times x plus 2, x minus 2. And that's it for worksheet number 20. There'll be another video for worksheet 21.